Hey everybody, let's do the second page, although I realize I ended without filling out these bar charts here at the end of the front page here. So one thing to keep in mind is that the total amount of mechanical energy will never change. So I'm just going to say 10 joules represents filling this all the way up. And so on every single one of these, we'll fill up our total mechanical energy the whole way. As long as there's no friction, then we won't lose any of this total mechanical energy here. Now, the potential energy in the first one here, it's all potential. So we could fill that one in there. Same thing on this last one over here, it's all potential, so we could fill it in there. On this one, we have no potential, so we'll leave that blank. And here, 2 joules are potential, so on my graph, 2 joules would be 1 bar there. And so then the kinetic energy here, well, on the first and last ones, we don't have any kinetic energy. On this one, all 10 joules are kinetic, so we'd fill that one all the way up. And then on this one, 8 joules are kinetic, so we would fill up 4 of the 5 bars there. Now, moving on to the back page here. So it says we've got an object starts from rest. It's got 600 joules of potential energy, so it's got that up at the top and it falls. Then after it has fallen to a height of 1/4 its original height, then its total mechanical energy is, well, as long as there's no friction, the total mechanical energy will still be 600 joules. Its potential energy, though, will only be 1/4 of this. Since potential energy is mass times gravity times height, 1/4 the height, 1/4 the potential energy. So we'll only have 150 joules of potential energy, which means the rest of it has to be kinetic. So that means now we've got 450 joules of it must be kinetic to get us back to a total of 600 there. So now let's look at this roller coaster here. We've got these different locations, A, B, C, D, E, and the first thing they tell us to do is to rank the locations according of increasing total mechanical energy, in other words, smallest to largest. Well, the total mechanical energy never changes. So A is equal to B, equal to C, equal to D, equal to E there. Next one says rank the locations according to increasing potential energy, smallest to largest. Well, once again, since gravitational potential energy has to do with height, the more gravitational potential energy here. So the smallest will be B, because it's on the ground, then E, then D, then C, then A. So we're just going in order of increasing height there. And then finally, rank them according to kinetic energy, smallest to largest. Well, wherever they have less potential energy, they'll have more kinetic energy because the total has to be the same. So we just flip this. So A, C, D, E, B will be the ranking in that case there. Then the next one here, the last part with the roller coaster and the bar charts. Let me grab that from the stack over here. So we have to see, first of all, the easier part is we can see right here that we have at the very end 40,000 joules of kinetic and no potential. So that means we have a total of 40,000 the whole way. So if we look here, we have 0 potential, so we must have 0 kinetic, so we must have 40,000 potential. Here we're also on the ground at D, the same as this, so this would be 40,000 kinetic and 0 potential. This spot right here is also on the ground, so it would also be 40,000 kinetic and 0 potential. Up here, it says the potential is 20,000. Well, we need a total of 40,000, so the other half, the other 20,000 must be kinetic. Here, 25,000 is kinetic, so the other 15,000 must be potential. Here, 5,000 is potential, so the other 35,000 must be kinetic. And then here, 7,500 is potential, so that will leave us with 32,500 is kinetic there. So now let's fill out our bar charts here for A, B, C, D, and E. So first thing again, total mechanical energy is going to always stay the same, so I am going to completely fill up my total mechanical energy bar on each one of these. Since my biggest is 40,000 and there's 5 bars, I'm going to say each bar is worth about, it would be 8. Each bar will be worth 8,000. So in part A here, all of it is potential energy, none of it's kinetic. So I'm going to completely fill up that potential bar. I'm just going to do all the potentials here. B, it's halfway, so half of it is potential. And then at part C here, 15,000 of its potential, so just shy of 2 bars. And then at D, none of its potential, we'll just leave it blank. And at E, 5,000 is potential, which would be just shy of 1 bar there. Now let's go back in and fill in our kinetic energies here. So in part A, we have no kinetic, leave it blank. In part B, half of it's kinetic, so 2.5 bars there will be filled in. At C, 25,000, so that will be just over 3 bars. And then part D, it's all kinetic, so we'll just completely fill that up. And then part E, 35,000 of it is kinetic, so that will be just over 4 bars there.